using a tube on the end of this to reduce the noise. This is a cheap generator with a 250 volt and a 12 volt output, and we're using the 12 volt output. It's a very rough output, it's quite spiky and will go up to spikes of 25 volts or so into this electrolyzer, and you can see gas bubbling up through here, and it's being fed into the carburetor intake. I've measured the voltage with an AVO meter. I don't like digital meters. Going to this, it's 14.5 volts at 3.5 amps, and we measure the output here, which is 770 watts going into an 800 watt heater. At the end of that, it's then feeding into the house, and I measure the total amount of energy using this meter here. It's just stopped, so we'll take out the meter and see what it's read. Oh, 280. Well, without HHO, I'd have expected that to be 300. So HHO has got a little bit of progress to make before it saves energy. Here's the next test. I use a standard jar of petrol for each test. It's 220 cubic centimetres, and that should in itself provide 2 kilowatts. So when one only gets 300 watts, 2 kilowatt hours. So when one only gets 300 watt hours out of that amount of petrol, it shows how much energy one really wastes with petrol engines. Now we'll plug in our load. Now we'll measure the voltage on the... I've put in a capacitor to smooth the voltage to the electrolyzer, and we'll see what... Without it, it was registering an average of 14.5 volts, and in fact with that capacitor it's registering the same, but this is a smooth current rather than so much pulsed current as pulse voltage as before. So we'll try this again. This has just stopped, so we'll unplug the meter and see what that experiment has done. So that did 0.299 kilowatt hours. So that was very close to the 300 that I've been expecting without the HHO. So we'll do another experiment.